Hi, myself Venkanamur, Associate Professor of EC Department, St. Martin Engineering College. Today I am going to talk about memory organization of 8051 microcontrollers. This is one of the important concept in the microcontrollers, right? So let's see what is the important of memory organizations in the 8051 microcontrollers. So before discussions of age memory organization, so what is an microcontrollers? What is an microcontrollers? Microcontroller is a single integrated circuit which consists of all components of the system like a processor, memory, and interrupt controllers and other peripherals along with the oscillators. Everything inbuilt of the microcontroller. So microcontroller is also known as system on chip. It is also known as system on chip. So microcontroller was introduced by uh, Intel Corporation in the year of 1981. So here we are talking about 8051 microcontroller. That microcontroller it is which is made up of metal oxide semiconductor technology, and it was introduced in 1951 by the Intel Corporation, sir. And so let's say applications of microcontrollers, where we have to use these microcontrollers. And so today most of the advanced applications like traditional applications of embedded system based on the embedded applications only. So as we know that embedded system applications which is divided into two types of applications, right? So what I am saying here, embedded application is based on microcontrollers, embedded applications. So embedded system applications can be defining as an embedded system applications can be defining as an electronic electronics application system and electromechanical application system. Electromechanical application systems. So here, whereas in electronic application system, it is must be required operating system and processor. Processor nothing but is the CPU. Okay, must be required operating system and the processor. And here, whereas in electronic system, it may be required operating system or processor may be required. And processor. So let's see today electronic applications. We can go through that. There are many of electronic applications are there. It is completely dedicated with the operating system. And let me introduce mobile phone. So it is very familiar and popular applications today. Mobile phone. So this mobile phone, important. It is important element or important core element. It is what? Processor only. But here we are discussing 8051 microcontrollers. It is very basic microprocessor. It was microcontroller. It was in 1981 process. Still we are learning about these microcontrollers. So it has to providing the basic fundamental to all advanced microcontrollers. So let's say we can say that family of microcontrollers like, so advanced microcontroller today well known processor, it is ARM processor. ARM, it's a family of microcontroller. So it is advanced, ARM is advanced to the 8051 microcontrollers, and it was introduced in 1995, ARM processor. Okay, and important element, important device for the application is processor only. Okay, so that's why here we are going to learn about the 8051 microcontroller, which providing the all basic fundamental to all advanced processor which we are using today in advanced modern applications or in the advanced applications, right? And let us see that processor specifications. Here we are talking about 805 microcontroller, that processor specifications and their applications. Look at here, these are the all applications of microcontrollers, and microcontroller applications, it can be used in consumer electronics, and it can be used in home appliances like TV, VCR, video cams, and camcorder, music instrumentations, home security system, and all the home appliances we have to use the microcontrollers 805. As well, we can use in the communication system also. Just now I have introduced it, mobile phone and intercoms and answering machines, paging devices, etc. And here we can see other applications like mobile automotive applications, airbag system, and ABS engine control system, and transmission control system, and temperature control system, many of automobile applications. These are all list of applications of microcontrollers. Okay, and next, and their specifications of 805 microcontrollers. So controllers size, processor size always will be calculated in the bits only. Now it is 8-bit microcontrollers. This processor can able to perform 8-bit operations only, and it has 8-bit data bus, 8-bit data bus, and 16-bit address bus. This processor, it can able to access up to 64 kilobytes of memory, because it has 16 address buses are there, and which consist of on-chip memory such as random access memory and read-only memory, and port input and output port, timer circuitry, and serial communication port, and external communications memory. So yeah, this all the devices we will discuss in the next slide. Yeah, look at here. This is the 8051 architecture. This is complete architecture, and we can see this is two architectures are there. This is also kinds of architecture. So look at this architecture, and just now I have introduced the specifications of the 8051 microcontrollers, and here, and we can see on-chip memory and such as RAM and ROM. RAM and ROM. There are two on-chip memories are there, and which are connected to the all general purpose registers and special function register, and RAM, which is connected to the all general purpose register. There we can see here, and accumulator register, base register, and PSW register, and which are all connected to the ALU only. And you know about this ALU to perform the arithmetical and logical operations of 8051. And here we have seen that some of the general purpose register, set of registers here, and those are all considered as a general purpose register. We know about that accumulator, base, and program counter, data pointer register, along with the PSW register. These are all set of general purpose register. So in the next slide, we'll discuss brief on about the those registers, right? And here, and this all comes 8-bit registers only. Accumulator, base, and PSW registers are 8-bit register, and program counter and data pointer registers are 16-bit register. 16-bit register. Except these two registers, remaining all are 8-bit registers only. And this here register, which is divided into two types of in this architecture, general purpose register and the special function register. Here we can see all the general purpose register in the above interfacing, and here we can see all these special function registers, like these are all set of special function register. Okay, and this is a control unit. This is complete control unit, and which are contains in the internal RAM structure. In the next slide, we'll give brief on this on the internal RAM structure. Okay, and here, and systems and system interrupt timers and data buffering, memory and control, everything which contains in the all special function pins are there, and I will give all the brief and their functionality in the next slide. Just this is the architecture, and this microcontroller consists of 4 ports. Their name of the ports are port 0, port 1, port 2, and port 3. And port 0, which consists of all general purpose input and output pins, and it is port 0, it is act as a input and output, and also it consists of pins are demultiplexed pins are there. multiplexed pins, those are the address pins and data pins. All the lower address and lower data pins contains in the port 0. And port 1, it consists of only general purpose input and output pins, only 8 pins are there. So, and port 2 is contains only addressable pins, that is higher addressable pins A8 to A15. And port 2, all the ports used as an input and output, and port 3 it consists of other special functions pins are there. Such pins are here: read and writable pins, and serial data pins, and counter and interrupter. So what does all the pins functionality, we'll discuss in the next slide. And now just I have shown the diagram, architecture diagram of 8051 microcontrollers. Yeah. So here we can see, we'll discuss each and every blocks here. Just and let's talk about the CPU of 8051 microcontrollers. The 8051 microcontrollers CPU to perform arithmetical and logical operations. And RAM stands for random access memory. So microcontrollers has 128 bytes of RAM for the data storage. So likewise, it has two RAMs are there. One RAM named as the lower RAM and the upper RAM. Each RAM size is 128. So complete of the RAM size is 256. And it is a volatile types of memory. It is a non-permanent memory. Volatile is nothing but is a non-permanent to store the data. And if the power is destroyed, power is turned off, data has been destroyed. So that is a volatile memory. Volatile nothing but is a non-permanent. And about the and random access memory, which consists of registers and banks and temporary storage data elements, which are special function registers. Okay, let's talk about read-only memory. Read-only memory, it's a nothing but is a code memory or the system memory or the instructions memory. So read-only memory to perform read operations only. And in these microcontrollers, read memory size is 4 kilobytes memory, and it is a non-volatile memory. It is a non-volatile memory. It is a permanent memory. And ROM memory is also known as one-time programmable memory. One-time programmable memory, and that we'll discuss brief on the next slide. And here, and I said you that 8051 has 16-bit addressable, and it can able to access up to 64 kilobytes of memory, and it is 2 to the power of 16 is equal 64 kilobytes. So the accessing capacity of this microcontroller is always depends on the number of address buses. So in this microcontroller consists of 16 address buses, and 2 to the power of 16 is equal 64 kilobytes memory. That is the addressing capacity of 8051 microcontroller. And this processor consists of timers and counter. So it has two timer, that is timer 0 and the timer 1, 0 and 1. And here timer 0 and 1. So each timer size is 16 bit. Each timer size is 16 bit. This is a powerful feature in the 8051 microcontroller timers. Okay, so there is a two timers is available, timer 0 and the timer 1. Timer 1, right? So each size of the timer is 16 bit. 16 bit. So this timer it can able to count 65,536 clock pulses. So 2 to the power of 16 is equal 65,536 clock pulses. That is the ability of the timer 0 and the timer 1. Both timers can able to count 65,536. So but this our processor 805 microcontroller, it can able to support only 8-bit operations. Then what we'll do here, we are going to divide it into timer 0 into 8-bit register and the 8-bit TL0 and TH1. Timer 0 lower bytes and timer 0 higher bytes. It is an 8 bits. It is an 8 bit and it is also an 8 bit. Both are 8 bit and 8 bit. So each timer can able to count it 256 clock pulses. Clock pulses. It is also 256 clock pulses. 2 to the power of 8 is equal to 256. And similarly, timer 1 also it can able to count this many clock pulses. But timer 0, it is act as a timer and the counter. And timer 1 also it is act as a timer and counter. Act as a timer and counter. Right? So what does timer and what does counter in the microcontroller? So what is the role of the timer and counter in the microcontroller? So timer, it is used to count internal clock pulses of the system. So those clock pulses which are provided by the oscillator, inbuilt oscillator. So oscillator has generated some amount of the frequency. That frequency clock pulses is counted by the timer. So how much it is provided the clock frequency? This 805 microcontroller oscillator has provided 12 megahertz of the frequency. That is approximately to the 11.0592 megahertz. So 12 megahertz of the frequency generated by the oscillator. That frequency is counted by the timer. So timer always used to count internal clock pulses of the oscillator. And now let's talk about the counter. Both are timer and counter, both are counting the clock pulses only. But timer it is count the internal clock pulses, counter it is count the external clock pulses, right? So based on the requirement, where it has to use the timer and where it has to use the counter, so its application has to decide with, right? So now both are counting the clock pulses, internal and one is the external. And here, so special function, a special feature of the microcontroller is provided the timer, but other processor it is not. And so we have seen that timer operations in the microcontrollers, and they are playing very major role in the microcontrollers, and they are used to count it timer clock pulses in the processor and external and internal. And in this microcontrollers, interrupt. So interrupt also is important when the device is required for interrupt operations. Like we have total five interrupts are there, so that we will see these are the specifications. And the oscillators, it just now I told you that it is provided the frequency 4 megahertz to 30 megahertz frequency, and their baud rate is 9600 bit per second. And so let's start memory organization concept. So as of now, we have seen that all the specifications of the microcontrollers, and let's discuss the memory organizations. So how the processor is organizing the memory, so internally and externally, that we are going to see here. And first we'll talk about the internal memory organization, then we'll go for the external memory organizations of the microcontroller. And this processor consists of two memories. One is the program memory and the data memory. So program memory is also known as read-only memory, and data memory is also known as data memory is also known as random access memory. So about the read-only memory, it's a permanently save the program being executed the code, and random access memory is a temporary storage the data and intermediate the results created and sent the during the operation of the microcontrollers. And that we are, so let us see. And data memory, first we'll talk about the data memory. And data memory already have introduced their specification in the microcontroller. So data memory, which is available in the two format, and in this microcontroller, data memory is also known as random access memory. So in this microcontroller, two RAMs are available. One is the lower RAM, 128 bytes, and upper RAM. Upper RAM is also 128 bytes. 128 bytes, lower and upper RAM. So, and their internal organization of upper and lower RAM internal operations of internal memory internal architecture of RAM. So we can see upper RAM and the lower RAM and their addresses, occupied addresses. So lower RAM always will start from 00H2 7FH, and upper RAM they are addressing starting from 80H2 FFH. So, and look at this, and thus that organization will see in the slides. And these are all working registers. And look at this is a complete upper and lower RAM, their addresses, internal memory organization of RAM. So RAM which is divided into upper and lower, and here this is the lower RAM, their address bit addressable starting from 00 to 002 and 07, and now here 07 bit addressable, and first 32 bits are occupied by the bank registers. So here 4 banks are there, so each bank is 8 bit, so 4 banks of 8 register. So this bank register is 8 and this bank register 8. So 4 8s are 32 bits bank registers are there, and remaining rest of the memory 202 to have 16 bit memory. It's a byte addressable memory. So 202 to have memory it is there, no, it's a byte addressable memory, and 302 7F. So that is a general purpose memory space, and here we can see complete their structure of the internal RAM structure of the lower RAM and upper RAM, and so this first 16 bit occupied the general purpose registers. So that is all bank register to occupy these memory locations 002 01F, and 202 2F it is a bit addressable memory, and 302 7F it's a direct and indirect addressing memory, and rest upper RAM is there, no, upper RAM to occupied 802 FFH. This is the upper RAM 128 bytes. Here is written that upper RAM 128 bytes indirect addressing only. Okay, and how to select the bank registers? I said you that 4 banks here. Okay, their name of the banks is bank 0, bank 1, bank 2, bank 3, and for the selection of their bits is available in the PSW register, program status word register. So selection of the bank here RS1 and RS0. If there are both are 00 and 01, 10 and 11, and to select the bank 0, bank 1, bank 2 and bank 3, and their starting address is also is given. The range of the bank addresses, bank 0 address is starting from 00 to 07H, bank 1 address starting from 0 here is 01 to 001 to 0F, 10 to 17. These are all their addresses, bank register addresses. Yeah. So look at here, and this is a complete internal structure slide it is. Now we can see easily we can understand. So banks here, and they occupied the addresses bank 0, bank 1, bank 2 up to bank 3, and there is occupied the addresses 002 and 002 and 1 half and 202. 2 half is the 16-bit addressable register. 302 7 half is the general purpose register. This is the uh, lower RAM, 128 bytes of lower RAM. Lower RAM to occupied 00H to 7F H, and it is direct and indirect addressing modes is available and to access the lower RAM, and upper RAM only to address the and indirect address and direct addressing both. And here so upper RAM the starting address is 80H to FFH, 128 byte additional memory it is, and all the set of the register and special functions register, general purpose registers and ports, everything available in the upper RAM only. Okay, now here we can see all the setup. In the next slide I will show you clearly. And here we can see their occupied addresses now, and here 80H. So this is the upper RAM structure, upper RAM, and their address starting from 880 to FFH. Now we can see 80 to FFH, and in this this is a byte addressable, and here we can see these are all byte addressable 80, 81, 82 up to FFH. In the 80 there are bit addressables here 87 to 80 to 87, and here is not bit addressable, these are all not bit addressable, and 8 is the address of port 0, 8 is the address of port 0, right? And port 1 address is 90. So all the port and all the register, the specified addresses are there. Here we can see 80 address of port 0 and port 90 is the address of port 1. Here is mentioned port 1, and A0 is the address of port 2 and P3 is the address of port B0. So these are all the addresses, and every registers and every registers and all this is clearly is mentioned. All the special function register there are, this is a complete programming model, and we should have the knowledge on the programming model. And when you are going to design the code for particular applications, you have to mention the direct address and indirect addresses of the port and registers. So this is a programming model. Yeah, so just now we have seen that this is a selection of bank registers, and we have the divided the memory and the, and look at the, yeah, so we programming memory, and also known as data memory, code memory. And here, so when you want to expand this memory, right, so we need to connect additional memory. So already we have some sufficient of already processor consists of, so internal RAM is 4 kilobytes, right, and RAM is 128 bytes, ROM is 4 kilobytes. So when it's want to add the or expand the external memory, so we need to connect additional memory, so that is called as external memory. Now how much memory we can expand it, how much we can expand? Actually we have the unbuilt memory 4 kilobytes is available. When we need to expand this 4 kilobytes to additional memory, so we can expand up to maximum 64 kilobytes only memory. And there, and this on chip memory, the starting address here we can see 0000 to 4 digitable 0 to 0 FFH. Okay, this is the starting and end of address for on chip memory. And suppose to want to expand another 60 kilobytes of memory, so already we have on chip memory 4 kilobytes, 4 kilobytes plus. Okay, so we have discussed programming memory organization of 8051. So this is the topics we have discussed. Thank you.